This is the most complicated we're going to get with energy transformations. It's not always going from potential energy to kinetic energy. This problem, for example, goes from kinetic energy to potential energy. So let's start it out. It's not going to tell you what formula to use. You have to figure it out from what it asks for. So it says you've got a 0.3 kilogram volleyball. Okay, I've got a mass and a force. All right, we haven't done force in a while. Whatever. Force, 100 newtons. That's a kilogram. What was its acceleration? It says it's going to make it accelerate up, so that's going to be important in a minute. It's going in the up direction. What was its acceleration? Okay, we got to figure out its acceleration. Gave us mass, gave us force, asked for acceleration. Sounds like this is a F equals ma problem. So force is 100 newtons. Uh-oh. They're still in burrows. Force is 100, mass is 0.3, acceleration is what we're looking for. So I've got to, it says a times 0.3, I wanted to say equals a. I'll divide both sides by 0.3. And this is a big old bear, I guess. 100 divided by 0.3 is 333. That's acceleration, so it's in meters per second squared. All right, so that's an easy question, I guess. We got that question answered, acceleration of 333. So now, it's taking us further. It says if it had this acceleration for 1 second, okay, so its acceleration is 333. For 1 second, that's how long it's going to take. There's a time. What was its final vertical velocity? So this is the bear's, I've got a picture of a bear over here. This is the bear. The bear is hitting this volleyball and it's applying its force from about here to about here. And right here is where its final velocity is going to be 333, and then it's going to go up like that. There. Okay, so it asked for its final velocity. In this other question, it told us it batted the volleyball from rest, so that's kind of hiding over there. So VI is 0, and that's all we got. We're not using 9.81 in this, it's just about what the bear is doing here. We're pretending like there's no gravity. It did not mention displacement, so I'm going to use the formula. It does not mention displacement. So final velocity is what we're looking for. Initial velocity is 0. Acceleration is 333. And time is 1. And 0 plus 333 times 1 makes our final velocity 333. So that's its final velocity from rest to right here, and then it's going to go up from there. Now down here, it asks what height did it reach. There's two ways to do this. So I'll show you one way, and I'll show you another way. So we could use its kinetic energy right here, and then it's going to turn all that into potential energy. So let's do it that way first. We've got a velocity. The thing is going 333 meters per second. Its mass is still 0.3. And let's find its kinetic energy down there. Now what we're going to do to find its height, we find its kinetic energy down here, and then we're going to plug it in for PE like we've been doing, except it's a little bit backwards now. We figure out how fast it's going down there, we figure out how high it's going to go up there. It'll change all its kinetic energy into potential energy once that ball stops at its maximum height. So all right, let's use our formula here. KE equals 1/2 mv squared, and I'm going to plug that in right over here. 1/2 times 0.3 times 333 squared. That gives me a big old number. What is it? I got 1633.35 joules. That's a lot. That's a lot of joules. 16,000 joules. Okay, that's my kinetic energy. So now I can plug that in. Let's see, I'll use the green marker now. That's going to all translate into PE. So I've got that much. I'm just going to write 16K instead of that big number. 16 kilojoules. The mass is still 0.3. Gravity is negative 9.81. And now we can figure out how high it went. So we're going to use, where can I do this? We're going to use PE equals mgh. And PE is that 16K number. I'm going to plug that whole thing in. I just don't want to write it. Mass is 0.3. Gravity is negative 9.81. And we're solving for h. So I've got to multiply these. So 16 kilojoules, 0.3 times negative 9.81 is 2.943. Oh, negative 2.943 h. And I divide both sides by that negative 2.943. And now I've got to divide those. It went 5,000 meters high. So when there's no gravity, we're pretending like there's no gravity still. Well, I guess we are. This will work. But I guess that's just a lot of energy that bear gave that ball. So all right, the bear gave the ball so much energy it went 5,000. It says I actually got 5,651 point something, but I rounded it. So that's my height, and that's negative. But we're saying how high it went, so it really doesn't matter if you say negative or positive. That's the way I'd like you to do it. There is another way. So we could use kinematics to figure it out. If we say it starts off at 333 here, so instead of using PE and KE, we could say its initial velocity down here is 333, and its final velocity up here is 0. We can do that. So let's see if I can draw a line right there. Final velocity is 0, initial velocity is 333, acceleration is negative 9.81, and we're looking for how high it went. This did not mention time, so we'll use the formula that does not mention time. Zero is my final velocity, initial velocity is 333, gravity is 9.81, and we're looking for distance. So 0 squared is 0, 333 squared is 110,889. 2 times negative 9.81 is minus 19.62. Eventually I'm going to divide both sides by that 19.62, but I got to get rid of this one first. This is still plus negative 19.62, so I'm going to subtract 110,889. Okay, so now I've got negative 110,889 equals negative 19.62 d. We want it to say equals d, so it says d times 19.62, so I need to divide both sides by 19.62, and then I'll be done. Oh, it's still negative 19.62. And I get the same thing. I get that 5652 meters. So there's two ways to do it. You could do it that way or this way. I hope that helps.